Alright, so welcome. This is calculus 2, derivative of natural log. Oh, I said derivative. In fact, in case you haven't watched derivative of natural logarithm, make sure you go back and watch it because you really need that here. It's not derivative, it's integration. Integral of natural logarithm. Integral of natural logarithm. Alright, so we have already established that, you remember I gave you a certain question like this to integrate. So we said that this is going to be -1 ds. So what you normally do, you add 1 to it and divide by whatever you have here. And you're going to get s raised to the power 0 over 0. And it's going to be 1 over 0. Now, this is wrong, alright? Because looking at the graph of a natural logarithm is something like this. This means that from positive infinity to what? Negative infinity. And this graph of a natural logarithm is continuous. And if it's continuous, it has to be differentiable everywhere. And if it has to be differentiable, that means that it should be able to what? Integrate. So let's see how we are going to integrate this. Let's see how we are going to integrate this and try to solve questions on it. So let's assume we have a function of u. It's not always s, it can be a function. Alright, so let's represent that by u. Du is going to be equal to the ln of u plus c. Please, the derivative of ln s is what? In case you haven't forgotten. That is 1 over s. Then you take the derivative of the inside, which is s. And when you differentiate s, you get what? 1. Is that not so? Thank you. So when you multiply this by 1, it's still the same thing. And we are saying that integration is the very best process of what? Differentiation. So when you undo this, when you integrate this, or let's do cross multiplication. In fact, simply, when we integrate both sides as respect to s, this as respect to s, we know that it's going to undo this differential sign, and we get ln s. And when you get ln s, you see that this one too will be equal to, and the integral of this, we are saying that that is going to be what? So when you integrate 1 over s ds, you are going to get this back. So that is why we are saying that differentiation and integration is a very best process of what? Integration. So when you differentiate ln s, you get 1 over s. That means that when you integrate 1 over s, you get what? Ln s. Very good. So that is what we have on the board. Right. Learn by getting the concept. Alright? Good. So let's look at this example. If you have integral of 1 over 6x plus 2 ds, what is that going to be? Let me first give you this. What is this going to be? So we can see that this is not just x, but it's a function of itself. So we are going to let u be equal to s plus 2. And du ds is going to get you what? This is 0, this is what? 1. So du is equal to what? ds. So by substitution, we get 1 over what? U times what? ds is equal to what? Du. And when you integrate this, we get ln u plus c. Is that also? But u is equal to what? S plus 1, x plus 2. So we get ln s plus 2 plus c. So that becomes your final results for that. All right. Okay, looking at our second example. So now, what this is telling you is that anytime we have integral of, let's say, 1 over s plus b ds, this b is not going to affect anything. The coefficient here is 1, so you are just going to get ln s plus b plus c, and that is true for that. All right. Let's look at one more. Let's look at integral of 1 over 3s minus, and this is plus or minus. It doesn't matter whether here is plus or minus, it will not affect your results. Let's look at 3s minus, let's say 5 ds. We are looking at a case where the coefficient of the denominator here is what? A constant. Can be 5, 4, 5, 8, 7. It can be 4, 5, 6, 7, anything, alright? So we let u be equal to 3s minus 5. So du ds will be equal to 3. You see that? So to make ds the subject, you get ds is equal to du over 3. So by substitution, we get 1 over u, and ds is what? Du over 3. Here we know that the constant here should plot out, and that is 1 over 3, integral of 1 over what? U du. Very good. So having this, we know that when you integrate 1 over u, you are going to get 1 over 3 ln u plus c. But u is what? 3s minus 5. So 1 over 3 ln 3s minus 5 plus c. Wow! Look at the difference here. Look at the difference here. Here you will not get anything here if the coefficient is 1. And here, if the coefficient is a constant, you get 1 over the constant. So in general, so all this is general, in general, if you have 1 over as plus b, this plus or minus. And when you integrate that, you're going to get 1 over the a, where the a stands for any number, alright? It can be any number. And you get the ln of as plus or minus what? The b plus c. Oh, I love mathematics. So that is what we have just established. Is that not nice? Alright. So, anytime you are given a question, like, you don't need to even go and calculate anything. You should be able to tell the answer and go your way. For instance, if you are given the 1 over 6s plus 2, you just know that the thing is 1 over 6 ln 6s plus 2 plus what? C. But please, if here is squaring, you have to be careful. Alright? And if here is square, if you get here to be square, definitely you get a parable here so that you can see what to do. Okay, let's look at another example. Alright, so having this, the one to pick as your u is very, 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 very important. So we say that you have already established by integration by substitution that your u is always inside of what? Something. And when you integrate that, the variable that will appear in the u should be inside of the what? Of the function. So when you integrate this, so when we let u to be equal to, when we let our u to be equal to ln x, we can get du dx to be equal to 1 over x. Is that also? So dx will be equal to cross multiply, you get s du. So by substitution, we are going to get integral of u over 3x times ds is what? S du. This will take away this. Alright. The constant we have here is 1 over 3. And the integral of square root of u is u raised to the power of 2 du. So having this, when you integrate this, then you are going to get 1 over 3. You add 1 to this to get half plus 1, then half plus 1, alright, plus c. And this is going to give you 1 over 3, u raised to the power 3 over 2, all this over. Now watch, to divide here by 3 over 2 plus c, this is the same as 1 over 3 times 2 over 3, u raised to the power 3 over 2 plus c. And finally we get 2 over 9. We know our u is what? Ln s. So ln s 3 over 2 plus c. So that becomes our final answer. And this solution is what? A general solution because it is embedded with what? U. Sorry, c. c. Oh. Keep on practicing, okay? Like solving calculus will be something like easy and faster for you. In fact, you will be solving it as if you don't care about any mistake because you know your concept. Alright? Good. You can also do that. Now, I'll be back. Now, we have already established from the reverse process in our first video of all these trigonometric words, all these three identity functions, the integral of these three functions. But you see that what if we have integral of tan? There is nothing like integral of tan here, and you can also see that there is nothing like integral of cot here, and there is also nothing like integral of sec here. This is sec square, not sec. So, and there is nothing like integral of cosec square here. So, sorry, cosec here. So, getting something like that, how are we going to get it? How are we going to do it? So, let's look at it now. No. So now, integral of tan s dx. We know that we can rewrite this. We can rewrite this as integral of sine s cos s dx. And let u, and you see, when you let u to be equal to this, and when you integrate, when you differentiate, you get negative sign. And that is inside of the what? Of the function. That is inside of the what? Of the function. So there are some integrals, I should have told you this long time in the use substitution. There are some integral functions whereby the derivative there are some integrals. This that I'm saying is very, very important as far as this course is concerned. There are some integrals whereby the function, the derivative of the function, when you say the function, let's say the denominator to be equal to u, the derivative of it is also embedded or included in the what? In the integral function. And that is what I'm saying here. Because looking at this, u is equal to what? Cos s. So du ds is going to be negative sine s. And we can get sine in here. So du is just equal to negative ds is equal to du over negative sine s. Please, this idea is very important. So by substitution, we get sine s over u multiplying by negative, and this negative can be here, du sine s. Sorry, in case you don't see it well. So you can see that this will take away this, so negative 1 over u du. And this is just going to give you lane u plus c. But u is what? Cos s. So negative lane cos s plus c. Knowing that this negative will be something like this, lane cos s, and the negative will be here plus c. Alright. I don't want to do this. So what we have there is the same as 1 over cos s plus c. But 1 over cos s is what? That is sec. So ln sec s. Therefore, the integral of tan s is equal to ln sec s plus c. You see how it is? So it's not that we don't have that, we have it, and that is what we have just established. Let's go to the second one, which is integral of sec. Yeah, we are going to do something, and you will learn it. Now, having this, I would like to multiply this sec s by 1. Alright, but I want the 1 to be sec s plus tan s. All this over sec s plus tan s ds. Please, this is the same as 1, and when it multiplies this, it doesn't change anything. Alright, so when you multiply this by the numerator, you get sec square s plus sec s tan s. All this over sec s plus tan s ds. Very good. We haven't changed the question, it's still the question. Alright. Oh, I don't want to play this. I hope you can see it well. Alright, so now we can now set, we can see now that when we set u to be equal to, when we differentiate sec, so when we differentiate tan, we get sec squared. And when we differentiate sec, we get sec tan. You see, the integral function is embedded with what? The function and its derivative. So here we can let u be equal to sec x plus tan x. So du will be equal to okay. So du is just going to be equal to, differentiate this, you get, when you differentiate this, you are going to get sec x tan x. And when you differentiate this tan, you get sec squared s. Sec squared s. Alright, so that is what we have for that side. Alright, so by substitution, we can see that here, we can see that the whole of this, where are we? Okay, here. We can see that the whole of this ds is what we have here. Please, I hope you can see what I'm deriving for you. The whole of this ds is exactly what? Du. Alright? So, we can now get 1 over, and we know that the down is what? U. 1 over u du. That is that. Because if you write the du here, we know that the top here is du. And when you write it here, the same as 1 over is du. So now, we say that this is ln u plus c. Alright? But u is sec s plus tan s. Therefore, we get ln sec s plus tan s plus c. Therefore, this means that when you integrate sec x, you will get ln of sec s plus tan s. Woo! Alright, please don't forget about the ln there. It's very, very, very important. It's not just there. It is there because it's there. Alright, so my marker. Alright, so looking at what we have established, we can now, I'm going to now rewrite all for you to add up to this. Trigonometric what? Functions. So one, add up. Add up to this. When you integrate tan s ds, you get ln sec s. Now let's go to it in general, okay? In general, because the s here can be a function, so let's use u. When you integrate tan u as respect to u, you are going to get sec u. You are going to get sec u plus c. And when you integrate cos u du, here too you are going to get ln sin u plus c. And thirdly, when you integrate sec u du, you are going to get ln sec u plus tan u. plus C. Lastly, 4. When you integrate cosec u du, you are going to get ln sec u minus cos u plus C. So please, I would like you to add up this to this. So this is all for you to get it off head. Alright? The moment we quote it, you should be able to come up with it straightforward. Alright, it's not difficult. You know that tan always go with what? Sec. In trigonometric identities, you know tan always go with sec. Okay? So when you integrate tan, you say that we will what? Sec. Alright? Ln sec. Don't forget the ln. When you integrate cot, cot, don't worry. Cot sine, okay? Make sure it get there. When you integrate sec, please, we have integral of sec square, which is tan. But integral of sec is sec plus tan. Ln of sec plus tan. And we have integral of cosec, which is, but is different from cosec square. Be careful, it's different from cosec square. Cosec square is negative cot. But when you integrate cosec, you get ln sec minus cot. Alright? Nobody forced you to do mathematics, so embrace it and you will keep on loving it. Alright? Thank you. See you in another video where we are going to talk about exponential functions or whatever. I'll be back.